Let's welcome on the stage Mikhail, Larchanka.
Okay, it works. Probably I'm the loudest breathing person you heard today, because usually when I breathe, somehow it reflects on the microphone. Yeah, you hear it. It will not be a funny presentation, or there will not be funny images or so. It's all serious, no code, by the way. And we are going to talk about the magic of data transformations. My name is Mikhail Larchanka, and I'm originally Belarusian, proud Belarusian. I would like to stay Belarusian forever, but we will see. And I work as a principal software developer in a company called Cytec in Netherlands. It's like outsourced company, but within a country. I have my website, which has nothing on it. I have YouTube blog, and I have my face on almost 1,000 videos, but every time when I go to the stage when I speak, I'm a bit nervous, sweating, and shaking. It all will go through the presentation, but that's what happens. And the plan of our presentation today is we're gonna talk about the problem of the data transformations. We will look at the traditional information factories. We'll talk about Azure Data Factories, but you can apply this knowledge to its analogs in AWS or Google Cloud. We will do a small comparison and a conclusion. And then you will have time for your questions, and I will try to answer them. And I hope we will do it in 40-45 minutes. And we're gonna start from problem of data transformations. As developers, we usually build something which works with data, right? And in most cases, friends of mine are usually building something which works with data on demand. So either you build a front end and then users go there, triggers something, and it works with the data, or it can be an API, where again, users go to some kind of interface, trigger something, and then API transforms the data, whatever it does with it, and returns back to the interface. But now we live in a world of the data where it's probably one of the most expensive commodities, I would say. And the companies who earn the data are one of the most expensive companies in the world. You can easily name them. It's Apple. They have all the data about mine, for example. Then it's Google, Amazon, who else? Meta. Name any other companies, they usually just have a big bunch of data which they sell to advertisers, or like Apple doesn't sell anywhere, sell to itself, and just knows everything about you. And because we have a lot of data in this world, we not only need software which works with the data on demand. In many cases, we need to do something with data, even if nobody requires this data. And there's a simple example from FinTech, it's a currency exchange. I will use this example through the presentation. And despite currencies are usually really volatile, and you can see how often in seconds or in minutes they can change price against each other, in software, we usually need one price in the end of the previous day. If we are talking, for example, about bank application where I work right now, we need currency exchange in all our projects from yesterday's evening. So as soon as market closed, we need this information to work with this on the next day. And because market closes when nobody really uses our applications because it's like internal app, so Rabo, my bank is called Rabobank, Rabo employees are already at home. And of course, the data itself appears at 9 p.m. if I'm correct, so there is no person who can take this data, do something with this, and put somewhere where we can use it next day. And it means there should be a mechanism which does this for us. And barely we need the raw data, let's be honest. Raw data is usually ugly. You need to do something with this. And there are two processes how you can work with data. Usually they called, like most popular, ETL and ELT. And the core difference in there is when you change the raw data to the data you can really use. It's always extract, so that's how you grab data from the source. Load, in this case, in ETL it's in the end, and here it's in the middle. It's when you push this data to your database or whatever place you want to store it. And the transform is the process of changing raw data to the format which is data, when this data can be used in API or on the front end. And you can do it before storing it, or you can do it after it's triggered. As user needs it, you grab the raw data and transform. And the thing is that if you do it on demand, it's really expensive. Because, for example, if it's done on the front end, it means that powerful computer of the user will do some transformations, will store the data, it will cost, it's performance cost for the computer he has. And we never know how quick and how fast and how powerful the computer of our user is, so we barely want to put all the load on the computer of the user. That's why the most popular nowadays method of working with a big raw data is to transform it before really storing it somewhere. So we grab the original data, do something with this, and then store. And later this transformed data or I don't know, normalized data can be used. And when I'm talking about the transformations, I'm usually mean few things. It's a filtering. I will show you example with the currency exchanges, and there are a lot of currencies coming, and there are, for example, I don't know, Chile peso to USD, Chile peso to euro, and because we work in Europe and Netherlands, we never need currencies against USD, so we need to filter it out. Aggregation. It means you have different data from different sources which have something common, some relationship, so during the transformation you can just combine them. Then you have joining, when you have some raw data, and on your side you have some additional information which you want to add to the raw data. It means you add new one. And, joining, sorry, when you kind of also combine the data based on some common thing, and enriching when you just add additional information to the raw data you have. So you can filter it, add additional things to this, and then store. And that's usually how it looks. So we have some source of the data, one or many, it doesn't matter. So we have a source where the data is stored. We have a target where we want to store this data. Let's imagine currency exchange. We want to grab it during the night or in the evening or whatever. We want to do whatever we want to do with this data, and then we just store it in a database in our infrastructure. So it means every application in our infrastructure in Azure can securely connect to it through the internal Azure whatever communications and use this data. And the funny part is always happening here, in most cases happening here. And because we are talking today about data transformations, before storing it, we need some software to do it. And we will talk about two types of the software we can build. One is Information Factory, that's more developer thingy. And we have Azure Data Factory, that's mostly non-developer thingy. You will see why. And we're gonna start from traditional information factories. What is Information Factory? Information Factory is just a software, I would call it, it's just a code which connects to the source, does anything with the data, and stores it somewhere. And Information Factory is literally a code which you need to write. Here you can see a really simple Python script which grabs, it has many sources. You can see one source, second source, third source, and here it joins one piece of raw data with other pieces of raw data based on the same parameter. We have WWD, it's just an ID of the client. So we have a lot of data about the client from different sources. We can grab them all, and based on this ID, we can just combine. And later, any our API which is using this data will receive whole information about client with all the data or metadata from different sources. It's a Python one here, just because I think Python is the most easy language to do backend nowadays, and it's the most popular one, so I wanted to show this. And this is what you face with when you build these type of things. First of all, you need to have a whole team of people doing it for you. You need to write code, so it means you need developers. Probably not even one developer. So a team of developers. You need to write tests. Developers can do it. Then you need to build it. Before shipping it somewhere, you need to build it, store artifact, and then be able to update or roll back or whatever. You need to deploy this. So that's where sometimes DevOps appear. So we already have developers, we have DevOps. We need to test what we deployed. Of course, developer can do this monkey testing by itself, but usually we have a tester, and we need to monitor this. So you can see this is a whole big expensive team of developers, testers, and DevOps. And it will cost you a fortune to build sometimes this thing. And then when you deploy it, you can deploy it whenever you want, because it's just a simple code, whatever language you use. You can store it in Azure, or run it in Azure, you can run it in AWS, you can run it on-premise, or you can use some cheap VPS for €1 per month, where you can also run this code. And the thing with this code, how you're gonna run it also. Because this code is running without triggering, so you don't have anybody starting the transformation, grabbing the source, doing something and storing it. So it should be ran by itself. And we have a technology for this for many, many, many years. It's called cron jobs. Who heard about cron jobs here? So you know it's a scheduler, right? So you put there a command, it will run the script, and if you have an information factory, it will run your information factory, transform the data, store it. In this case, I'm talking about Azure because we work mostly with Azure. With Information Factory, you have another possibility. And you can see it here. It's not really visible. You see here trigger, trigger, and trigger. So it means it's happening on the schedule. But you can also see here HTTP, 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 and HTTP. So you can also expose some endpoints. So it can be an Information Factory and an API at the same time, which is really useful. And you can also use, I didn't cross all the languages, but we will go through it. You can use almost any language you want. Of course, you cannot use HTML to build data factory, CSS in here. Just found this picture and try to cross out. You cannot use JavaScript from this picture. You can use JavaScript from this picture. This is front end, this is Node.js. You can use Swift if you want. There is possibility to build backend with the Swift, but you can also, you will not do it here. But all the rest of the languages, you can add here Rust, whatever language you like, you can use to build Information Factory. But then you need developers who know this language, and if it's like Elixir or Rust, it's going to be pretty expensive. And supported is also expensive, so it doesn't sound really good for some simple services. And that's where Azure with data factories come. Or there are analogs in other cloud providers, AWS, Google Cloud, whatever. And what is Azure Data Factory? It's a fully managed, cloud-based data integration. It's a piece of software which is built with help of Microsoft, in this case, which you can also run when you need based on the schedule, and which will do exactly the same. It will connect to your source, grab the data, change the data, and store it somewhere. But this one can be done without developers. You can, of course, hire a lot of experienced developers, and they will do this for you. This is just a configuration, a plain JSON file for Data Factory, which just describes steps and actions which Data Factory will do. And it's really hard to program. It's not like development. It's just you need to know how the names in the Azure is, etc. So you can do this. But nobody uses data factories like this because they have a graphical interface. So you can just open a web page, select your subscription, select your enter ID, select your subscription, create new data factory, and start working with it. You don't need to know programming language. You don't need to know what is database, how it works, whatever it does, where you store it. You just need to know how to drag and drop. Like this. It's pretty simple. So interface looks like any other editor. You have some kind of components here which you can create by yourself. What do we have here? Pipelines, data sets, data flows. Again, there are kind of some best practices how to structure all of this. Nobody really cares. And you just create the stuff here, and then you just drag and drop it on the screen. So we've created data set. This is exactly the data set which connects to the exchange rate server, grabs currency prices, and then transforms it and store it. And it's so easy that you can even create any connection pretty simple. Let's assume you want to connect to the data and verify if it's successfully received or not. You don't need to write any code, error handlers or whatever. You just drag here, if successful, if unsuccessful. And you can create some actions based on this. For example, for unsuccessful here, we have an email to be sent. So if we didn't receive currency exchange, currency prices, we will just send email to our functional mailbox that something wrong with the data factory, and we can go check and maybe run it manually. You also have a whole set of different connections predefined for you by Microsoft, which sounds pretty cool until you face with a connection which is not supported here. But what is supported? You can connect to file storage within Azure. There are many of them different ones. For example, here we have a blob storage, so you have connection. If you want to connect with OAuth2 to some external server, here it is. You can create variables for your client ID, client secret, scope, whatever. Create a simple command to connect to endpoint to grab the token, and then just do your request with this token. Pretty simple. Probably everybody knows how OAuth2 works. And here you can do it without writing the code. You can see you just drag here variable, put like where to take it, and that's it. And this is another type of connection. Who knows what is API? Let's say, how is it properly called? Proxy, I think. Usually you have this proxy installed when you have interconnection between two different services. If we have all of our source, target, and Azure Data Factory in Azure, we don't need this because it's an internal Azure communication. We just create virtual network, which is not accessible from outside, and it works. But if you want to do cross thingy from AWS to Azure or from on-premise to Azure, because I work in bank, it should be really secure. Now, they think this is secure. Okay. So that's why you have this proxy, which allows you to create OAuth 2 connection between two different sources, two different infrastructure programs, between two programs. So it's literally OAuth 2 connection, and also everything is predefined. You can use key vault if you want to securely store somewhere. So all predefined. You just drag to the screen whatever you want to use, provide the values, and it's done. Here is an example how it works. So we built a whole pipeline, and you can see here there is some transformation happening, grabbing the source. What's in there? 1. Okay, something 1. Based on the image, it's a filtering. Here we do, damn, what's written? It's not visible. But I think here we have cleaning up the data. Here we remove unused columns, and we store it somewhere. And you have ability to preview what's going on every step. You just click on a step, click refresh, and you can see how it looks. And you don't know how it's stored. In this example, we have a Parquet file. Who knows what is Parquet file? Yeah, so this is a Parquet file. Almost nobody knows what it is. I also don't know how it's built inside. If I open in text editor, it's just a piece of whatever it's in there. But here, without knowing it, I can see the structure. I can do whatever I want with the structure, can change this data on the next steps. So then I click here, I can see how it changes after filtering. So you can see here we have euro, pound, dollar, euro, pound, dollar. So we only need euro, so we will filter out all these GBP, USD thingies. On this step, do I have a picture? No. Yeah, that's, you can see here, we check base currency. Base currency, it's the currency against which we have the price. So dollar against euro. So I only need currencies which base currency is euro. So this is pretty simple. Looks like a JavaScript comparison or whatever, any other language comparison. But this is not literally a programming language. It's just special commands you can put in here. And we have DevOps doing this without even Python knowledge, and they're pretty good with building this stuff. Here you can also see all the possible transformations you can make. But the thing is, that's only ones you can make. So if you need something else, whatever, derived column, select, aggregate, so you can see. And it's all on an interface. You just drag and drop, change the data. You can see here also on this screenshot. You don't need to program a renaming of the columns. Imagine you do it with Python or JavaScript. You receive the data with some specific field names, then you need to create an object. You need to create new object where will be different names of the fields. Here you just put original name, put a new name. Again, no programming language. Everybody can do it. Sounds pretty good. I think that's it for here. And you just saw information factory is just a piece of code. You need to hire a team and build it. And you see ADF, just drag and drop. Yeah, some random person goes there, drags something, connects to the source. He knows something about it, and it's done. But which one is better? This is usually the question, and I will try to answer it right now. From the developers, immediately, from the developer's perspective, the better is to write a code, because that's what developers do. From the non-developer's perspective, it's usually easy to drag and drop. But what are the benefits of both to understand which one you can select or you can use? I have my notes here. Let me open it. So we will start from information factory. It's a custom code base. It's one of the characteristics, and for some people, it's literally an advantage, because you can write any code. You want to connect to smart contract in the blockchain and grab data from there, you cannot do it with ADF, because ADF doesn't have this type of connection, and you cannot build it. But here you can just write a code which connects to you or whatever, using some Web3 framework in any language. You connect to a smart contract and just receive the data. Scheduled services. As I said, you just create a cron job and it will run it. But I would also say here, I forgot to put that you can do it as an API, so you can make it more useful for other people also, who doesn't want to have a role, who doesn't want to schedule something. You can make an endpoint, and they will connect to it and grab the data on demand also. Data integration, yeah, that's just because what I've put here for this. Oh, okay. Data integration in this case here means for me that it's connecting to different sources and to different targets. And when you write your own code base, you can, as I said, connect to any type of the source and target. Transformation logic. Again, if you're a developer, you probably would like to write your logic by yourself. And if you know how to do it, you can easily write it. It's going to be or ugly or non-ugly, doesn't matter. But you have ability to write the whole transformation logic in the way you want to write it, in the language you want to do it. Loading and storage, of course, because we can store it anywhere, nothing specific, and flexibility and control. This is the thing which I think is the most important. Flexibility, it means you can really change code in the way you want. If something, some new requirement from the business, you can just go, it's your code or code of your team. You know how it works, you just change it in the way you want to change it, and it's done. And you have all the control over this code. But if we will look at this guy here, which is Data Factory, we have, again, scalability. Because everything Microsoft does in Azure, they say it can scale up or scale down based on the load. If you need more performance, we will give you more CPU, more RAM, or whatever. Flexibility, they call it flexible, because you also can connect to whenever you want and grab the data. But I would say flexibility here is a much, much lower than in Information Factory. And that's pretty clear why. If Microsoft didn't do something for you, or if it's a Google Cloud, they are now in Google Cloud or AWS, if they didn't do it for Data Factory, it means you cannot use it. You can't build it by yourself. Data integration, again, only for the data types they know. If they know Parquet, you can use Parquet. But if it's a format they cannot use, you can connect to the source and grab this data, but probably you cannot transform this data. Transformation logic. Again, predefined one. Everything we look in here is a predefined one. It looks cool if you will go to whatever resource to read about Data Factory. This all gonna be benefits. Oh, this all gonna be benefits. But it's all limited. And we had a conversation with Microsoft from the bank to add one thingy, one source, to support with one source. And they said they cannot do it because we are the only ones who want it. And for a company like Microsoft, if only one consumer, if it's like a bank or whatever, asks for the feature, they will not do it. No, of course, you can propose them millions. They will hire people and will do it. But usually banks is not proposing, they just do a request. Do something for us if you can. And for us, the answer is no, we cannot. We can help you with some bug fixes or whatever in the Data Factory, but we cannot to help you with new functionality to be added in there. So it's all limited, and you cannot bypass it in most of the cases. This is a really big advantage, because as I said, when you work in one infrastructure, it's really cool that you can connect with different applications in this infrastructure without additional proxies or whatever, because it's secure, you do a virtual network. And because Data Factory is a part of Azure infrastructure, it means it connects to everything in Azure without additional settings. Of course, you need to add some kind of endpoint within the Microsoft endpoint, or maybe some token or whatever, but still, you don't need to think about security around it, because all the security is done by Microsoft. And we will return to this in a couple of slides. Cost effectiveness. As usually all these cloud providers say, we will charge you based on the usage. So if users use your application a lot, you will pay. If they use not so much, you will pay less. And it's kind of okay. It allows you to control the cost, maybe optimize something. You see the load, you see the price, maybe change something in the Data Factory to make it faster and cheaper. But I have conclusion, and we will talk about this. What's better? Yeah? And this is a screenshot I want to discuss. This page is not interested. We already know this is. I think this is the wrong screenshot, by the way. This is configuration for Data Factory. We should have Python code in here. And this is a Data Factory. And this is a screenshot, which probably will make sense for many of you. This is something in Azure. Usually if you have access to, you have permissions and you go to some resource in Azure, you see how much money it costs to use this resource. And we have some prices in there. It's a pretty small price for the bank, right? It's 87 euro, 5 cents, 5 cents, and less than 1 cent. And this is Data Factory, this is storage, this is Key Vault, this is something else. It doesn't matter, 1 cent, it's not a price. And it doesn't sound so bad, if it doesn't look so bad if you think it's a bank. For them, like 87 euros, nothing. Let's be honest, nothing. Like. But what is it? What is this Data Factory doing to cost 87 euros? Nothing. Nothing, and it costs 87 euros. So it's exactly the Data Factory I showed. Once a day, it connects to the source, receives, let's say, 100 currencies, filter out only 5 of them, delete 2 columns from the data, rename other 2 columns from the data. It's like, come on. And stores it. That's it. So 30 runs per month for whatever, nothing. And it will cost you 80, let's say, 8.5 euros. You know how much will cost to run the same cron job, let's say on PHP? Who would guess how much it will cost? Nothing. It will cost the price of the cheapest PHP hosting on the market. Them. You can spend 2 euros, maybe 1 euro. There's some German VPS which costs 1 euro. You can put a cron job in there with a simple PHP or whatever, Ruby, Python, any code you want, and it will cost you 1 euro per month. Pretty cheap. And here you pay 87. And this is for the bank and the whole infrastructure, they don't really care. But if you build something for yourself or you're a small company, that's not the thing you want to do. So when you select what to use, let's go back here. When you select what to use, you're not only thinking, like, if you're not a bank, you're not only thinking about what's easy to build. Should I hire the whole team? Or maybe I need 1 person, well, I need to ask my DevOps to build this thingy. And it sounds like here's expensive to build, here's cheap to build. And maintainability is the same. But if your ADF is pretty complex, we have an ADF which connects, we have information factory which connects to 3 sources. Where is the screenshot? This one. Well, this one. It connects to 3 sources and it does a lot of transformations. So enriches data, removes unnecessary, checks. We have 12 hours data, 24 hours data, so it checks what exactly is the data and performs different things. And this whole thingy was built with Information Factory because it was hundreds times cheaper to run. It's a simple Python script which you run once per day and it's pretty quick. And if you will build this one for cheap, because you need 1 person, but it's going to be complex, it means that your price will start increasing. And as more data as you receive, Microsoft will give you more resources, and it means this price will rapidly grow. And with rapidly, I literally mean like 1,000 for ADF is not a price also. So ADF with 3, 4 data sources, which runs approximately like 15 minutes or 18 minutes, it will cost you more than 1,000 per month. And this one, by the way, it's another funny fact. This run, which does, you remember, nothing, around 10 minutes. I'm not sure if Microsoft especially does it so slow because you pay for the time of the resources. Because my PHP script, again, like simple, cheap, I can build it with ChatGPT in 2 minutes. I don't know, 10 minutes maybe. It will cost nothing. It will run nothing, it will not use resources. Here, this guy is using a lot. And as I said, when you select what to use, you look not only on the simplicity of building it, you look at the prices. And our bank is also now looking on some decreasing of the prices, of course, because we pay millions per month and economy and all the stuff and sustainability. If you don't know, in Netherlands, all these Greenpeaces or whatever, they blocks banks. On this weekend, they blocked Rijksmuseum, I think, because they work with ING. ING is another bank in Netherlands, and they think it's not sustainable. It uses a lot of resources, data, warehouses, or whatever. And all these Greenpeace guys are just blocking banks. It happened with our bank also a couple of months ago, just because we use a lot of money on the things which are not sustainable. And our bank now looks how to reduce costs. And I think these guys, this is one of the first who gonna be got it. So probably we will replace it with this Python simple thingy, which we will run. It's now a discussion in Rabobank, because ADFs are becoming super expensive, and storing of the data is becoming super expensive, which is also used here because it's the final target of your ADF. You just store it somewhere, and you pay for this. So if I would say what you should to select for your projects, for small startups, for non-big companies, you shouldn't even use Azure. So never use ADFs, and don't even use Azure or AWS. Maybe on-premise will be much cheaper. And who follows DHH? It's also a big topic nowadays. It's a guy who invented Ruby on Rails. If you don't know, he has a startup, 37 Signals, I think it's called, which sends emails. And they get rid of the cloud, and they have an on-premise, and they are paying, I think, for the servers they have right now, 800 something bucks per month. And previously they've been paying for the cloud, for the same thingy, 11,000 or something like this. So he has a whole blog post why they did it with all the year calculations, how much millions they will save on it. So if you're using something not big, don't use data factories, and then don't use Azure, AWS. This is a problem we discussed today with one guy here, that it's a problem of the thinking about a lot of your application, which probably will never exist. Like, we always build the software thinking we will have millions of users, so we need to build it from the scratch properly. Don't think like this. Prove your concept first with MVP, see if it works, and then just expand to the big and expensive clouds. If it doesn't work, just throw it out. So if you need some data transformations when nobody uses your application, but it should happen, just build a simple cron job, use Python, use Go, whatever language, and it will work. That's it, and if you have any questions, it's time to ask them.
So the first question, please.
Gifts.
Hi, thank you for the presentation. Maybe I missed a bit, but it sounds like there is no good case where to use this data factory. Or maybe you have any ideas where it works for this money.
I have an idea where it can work. It depends on the team. And at a bank, we have two ways of doing things nowadays. In my bank, we don't use front-end anymore. And we have front-end. In my area, we're starting to stop using front-end. And we're starting to use a lot of data factories and information factories like API, with API endpoints exposed. And this is because bank wants to reduce the costs. They started from shifting technologies. So we use Mendix. It's a Dutch no-code platform, which allows you with drag and drop create components and build interfaces and without real developers involved. And we use data factories to work with the data which Mendix then will use. So in this case, if you don't want to have all these expensive developers and you want to simplify the process like Ben, they want it to be unified, the same design everywhere, the same components, the same structure of the data, it's great to use Data Factory maybe for many projects. You just simplify. And of course, when I was talking about this simple 87 euros per month Data Factory, this Data Factory is used by many, many other applications in the bank. So it stores exchanges, and it means that this currency exchange, these prices of the foreign currencies, are used by other applications. Bank is multinational. We have office in Chile, United States, Canada. So all applications in all these countries using the same data. So it's not like we have 10 applications and 10 same data factories. It's one, and then it's kind of cheap. So this is a way you can use it. But it's a unified data factory. If you need data factory separate per application, it's expensive.
Next questions?
Hi, thanks for talk. In general, sorry, I cannot do anything with it.
I'll go here.
In general, any UI tool that provides, let's say, easy-to-go configuration has its own cost. And it looks like it may be simple to drop in some simple boxes and start transformation, but it may be quite challenging in case the pipeline itself is complex or big. From your standpoint, for what size of pipeline and what kind of pipelines is it good for in general if we like omit the fact of the cost at all, like UI versus code. Code may be stored and reviewed, and there is like proper SDLC applied to it. When it comes to the UI configuration, it may be like out of control.
Have doubts in the answer here, because I think it can be any size, because you can split pipelines in Azure on many small pipelines and just combine them in one later, and it works. But because of bad, like you have Git integrated in the data factories, you can have this Git version control or whatever. But it's a version control of the configuration files, and if you wanna, we have now a really complex data factory which has many changes, and you have many revisions of it, and we have like folders, 100, this is 100, version 100, and we have few pipelines in it. We have 200, the same pipelines but changing in it. And we have many, many of these folders. So if your pipeline is not like, if you're not building versions of versions on top of your pipeline, it can be any size. But if you later need to store old version and then new version and then again new version, and you just creating, is my presentation still available? I'll show, yeah.
Yeah.
Go. Yep. You hear 100 in here. This is version 1. So this 100 is here. You can see 100 arrow pipeline, 100 folder for data flow, and we have this pattern of working. So if I need to create new version, I will create exact copy of this with 200 and do my changes. And we have a data factory which has like pipelines like this, the same pipeline. Doesn't matter, big or small, but it's awful. And you start like looking at this, not understanding what is the last one, which is used where. But if you don't do versioning right here, and you split your pipeline on some kind of folder, so based on whatever concerns, what it does, you will split it properly here and make a structure. It can be any length, because later you just go here and you can combine small pipeline, another small pipeline, another. So for you, it will be one big pipeline, but if you work on this, you work on small chunks of this, then it's not ugly. Yeah, that's what I think. But probably some limitation should be done in there. I never heard about this limitation, but I would say 100 steps sounds like a lot. I wouldn't do 100 steps. And if we will take cost in consideration, definitely not. So I would say like this.
So, hello, thank you for your presentation. I have a question. Actually, this looks like a real heavy vendor lock. Doesn't this bother you or your bank?
It does. I'm not a UI designer or whatever, but I'm really really sad and really angry when I see something like this. That's awful. That's like Power BI copy, let's be honest. I'm like, don't like Power BI interface for some reason. And here it's like the same, but for data factory. So for me, it's overloaded. It's really hard to find something in here. If you don't know the name and you just try to find it, it's almost impossible. You cannot type something here, just open everything, and like, it's so small and useless. So I think that's bad, and using of this is also bad. So, but we have people, not developers, doing this, these type of things, and they are pretty happy. For them, it's like, nice, I can just drag and drop, all this typical user, which likes interfaces and drag and drop. For them, that's ideal. They know the names here, they search quickly. Maybe it's just how good you are or experienced with using this. I'm a bad guy to use this stuff quick. So I can do it, I know the names, but I'll do it slowly. So for me, Information Factory is much better approach and much more flexible, because as I said, it gives me more possibilities, and I sometimes work with Web3. So for me, grabbing data and transforming from this source is really important sometimes, and Azure Data Factory doesn't give you this ability at all. So yeah, that's bad. That's bad.
Hello, thank you for your talk. I have a question from another side. Yes, from your talk, we understand that Azure is expensive, and but why other company use it? And from legal perspective, Because if you're a small bank, it's hard to go through all this GDPR and other stuff. So how you solve your problem in your bank?
In our bank, it's not a problem at all. Because our bank wants to have everything unified. And if you have everything unified, you need to have one place where you store and run everything. We still have, like we're changing it, but we still have on-premise applications. We have applications hosted in AWS. So we need to connect to it sometimes. And nowadays, a bank, I don't know, there was probably a tender made by the bank, and Microsoft made the best proposal, so they selected. And now we just move everything in here. And it was in the beginning, though, nobody cared about the price. So probably proposal from Microsoft was so good, maybe with smaller prices. So in bank, some heads said, yeah, let's do it. Let's do it in one place. Doesn't matter. But now when all this green stuff and sustainability, and we all know that computers and data centers are eating like megawatts, whatever, how much megawatts, like cities sometimes, it means that it's not cost effective and sustainability effective. It means that for banks in Netherlands especially, they are looking at this and they are thinking how to deal with it right now. It's expensive, it's not sustainable, and all this is bad. So now it's another problem, pain in the ass, I would say, which banks tries to solve. But for them, they selected this just because it's one place which supports everything they need. Yeah, that's why it was selected. I saw a question here.
So my question, if you take out of the account the price and the idea that you're, as a bank, are going to possibly migrate a lot of factories into code, right? I've seen this stuff in SSIS packages that were developed like by business people, and my question to you is, realistically, do you fear having to rewrite this stuff into code? How is it for you as a developer when you come in and see what a business guy developed? What's the experience like trying to transfer everything into code?
I'm not scared, because when I need to write something, it means there's demand on my job. So they're going to pay me. So I'm okay with this. And that's perspective. I look at this as many non-devs or non-experienced guys will do something. It means much more job for me in the future. So I'm okay with this. And I don't really like this. I understand why bank wants it. It's pretty simple. Even like a business person can come here and like read if the naming is proper and say, it's wrong here, let's change it. But I don't like it. And I would like in the future if bank will say, this is crap, let's just rewrite it. And like, yes. My salary is pretty big, let's do it. That's how I see it. But probably, I don't like it one more time, but I think for many small companies, small banks, companies who hire external outsource companies to produce something for them, this is the way to do in the beginning because it's much cheaper and faster. In the future, it can be a problem, of course. But when you just start and you have not a big lot, not a big transformation or whatever, that's great. Then later they will come to me when it expands and say, let's rebuild it, and I will say yes. But for now, let them use it.